Welcome to the deep dive. Today, we have a really highly unusual mission for you.
Yeah, very unusual, but I think it's perfectly suited for a curious learner.
Exactly. We are taking a microscopic look at a piece of digital source material that you undoubtedly encounter on a daily basis,
Yeah.
but you almost certainly just ignore it.
Oh, absolutely. Everyone ignores it.
Right. Because think about when you walk up to a high-end club or like a secure facility, the security infrastructure is incredibly obvious.
Yeah, you've got the velvet rope, a metal detector, a physical bouncer.
Right, a bouncer making a very deliberate decision about your entry.
Hmm?
But when you navigate the internet, like clicking a link to an article or a storefront, you just expect those digital doors to simply fly open.
And when they don't, well, that's when you see our source material for today.
Yeah, that fleeting, mundane white screen, the one with the spinning circle telling you to wait just a moment.
Right, and we're going to examine one specific real-world instance of this today. Specifically, the security verification screen that triggers when you try to access the domain www.btwmedia.co.za.
Which is basically the digital equivalent of being paused at the velvet rope.
Exactly.
And while you might just perceive that, 5-second delay is a minor annoyance, or maybe assume your internet connection's lagging, that single web page actually contains a wealth of clues.
It really does. It shows the invisible architecture governing the entire modern web.
Yeah, it operates as the bouncer for BTW Media, quietly interrogating every single request that attempts to cross the threshold.
And before we can even understand how this checkpoint works, we really need to address why it's there in the first place. Like, what is the system actually looking for?
Right. So looking at the source details, the initial text on that screen states explicitly that the website, quote, uses a security service to protect against malicious bots.
Yeah, malicious bots. The delay happens because the system is actively working to verify that you, the user, are actually a human.
Which is wild.
It is, because the primary danger to a domain like BTWmedia.co.za is rarely a human being like manually attempting to guess an admin password. The real threat is automated scripts.
Now, wait, I have to push back a little here. I mean, we all know bot traffic is a persistent issue, right?
Sure.
But when you look at the sheer scale of these edge network defenses, it makes you wonder, is the internet really so overrun by these automated programs that a standard site like BTW Media needs a permanent guard at the door?
Oh, absolutely.
Are we just swimming in a sea of bots?
We really are. I mean, volume is the defining characteristic of the modern internet. Depending on the tracking metric you look at, non-human traffic frequently exceeds 50% of all internet activity.
Wow, over 50%.
Yeah. And bot operators, they don't usually sit there and manually select targets like btmedia.co.za.
Right, they cast a wider net.
Exactly. They utilize massive botnets. These are networks of infected computers and IoT devices. And they use them to systematically scan the entire IPv4 address space.
So they're just knocking on every single door on the internet at the same time.
Pretty much. They're looking for open ports, outdated plugins, unpatched vulnerabilities across millions of domains simultaneously.
Okay, that indiscriminate scanning definitely explains the necessity for a universal guard. I mean, a malicious script doesn't care if it's hitting a major financial institution or just a localized domain.
Right, it's just executing its programming. And in addition to vulnerability scanning, these scripts engage in stuff like credential stuffing.
Which is when a password database leaks, right?
Exactly. If a massive database of passwords is leaked from some completely unrelated platform, botnets will take those millions of email and password combinations.
And just test them everywhere.
Yep. They test them against every domain they can reach, hoping users recycle their login information.
Which people always do.
Always. And then there's data scraping, where bots instantly copy original content to republish on spam networks. And of course, the brute force approach of a DDoS attack.
A distributed denial of service attack, where the objective isn't even to infiltrate the server, right?
Right.
It's just to overwhelm it with so many simultaneous fabricated requests that legitimate traffic can't get through.
Exactly. The server expends all of its computational resources just trying to acknowledge the fake traffic, and that leads to a total crash.
So the security screen exists to absorb that initial wave of contact.
Right.
By forcing a pause at the velvet rope, the system protects the venue inside from being trampled by this automated mob.
That's a great way to put it.
Okay, so moving on through the source text. The screen transitions from stating its purpose to issuing a technical directive. It says, enable JavaScript and cookies to continue.
Which is a huge shift from how things used to be.
Yeah, it's a significant evolution from traditional CAPT CHAs, where you had to, like, actively identify traffic lights or crosswalks.
Oh, I hate those.
We all do.
Yeah.
But here, we're looking at a passive interrogation. You don't have to click anything.
Right.
But, I mean, asking a browser to just enable JavaScript seems like a relatively low bar. How does running a standard scripting language definitively separate a human user from a sophisticated botnet?
So the directive to enable JavaScript actually initiates this really complex, invisible challenge response protocol.
Invisible to us, you mean?
Yeah. When your browser encounters that screen, the security service delivers a highly obfuscated mathematical puzzle written in JavaScript,
Okay.
and your browser's engine has to parse that code, execute the computation, and return the correct cryptographic proof of work.
Oh, wow. So the browser is basically forced to expend local computational energy to prove it's legitimate.
Precisely. The whole goal is to invert the economics of a bot attack.
How so?
Well, malicious scripts rely on speed and volume. A bot wants to send like 10,000 HTTP requests a second using a very lightweight script.
Right.
It absolutely does not want to spin up a full heavy browser instance to execute complex JavaScript logic for every single target.
Because that would take too much processing power.
Exactly. By demanding that the client perform heavy computational lifting, the security service drastically reduces the speed at which a botnet can operate. It makes the attack financially unviable for the operator.
Okay, I get it. It's basically the equivalent of the bouncer asking everyone in line to fill out a complex calculus worksheet before entering.
That's exactly it.
A human visitor doing it once might not even notice the processing time, but an automated system trying to send a million fake attendees will just instantly exhaust its processing power.
It'll burn out trying to solve a million worksheets. And beyond the computational puzzle, the JavaScript serves a secondary, far more intrusive function.
Uh-oh. Intrusive how?
It's known as browser fingerprinting. The code actually interrogates your user environment to ensure it aligns with human behavioral and hardware patterns.
Okay, that moves way beyond a simple math problem. What specific data points is the script analyzing during those 5 seconds? Like, what is it looking at on my computer?
Oh, it analyzes a multitude of parameters. It checks the hardware concurrency, for example, to see how many CPU cores your device has.
Really?
Yeah, it reviews your screen resolution, your operating system, even the specific fonts installed on your machine.
Way it checks my fonts.
Yep. And one of the most revealing tests is canvas fingerprinting.
What is that?
The JavaScript silently instructs your browser to render a hidden 3D geometric shape, or maybe a string of text. And because different graphics cards, drivers, and operating systems render pixels with these tiny microscopic variations.
Oh, I see where this is going.
Yeah, the script can generate a unique hash of that rendered image.
And if that rendering hash matches the profile of known server farms or data centers, which typically host botnets, the security service immediately flags the request as suspicious.
Exactly, and it doesn't stop at hardware. The script also monitors the heuristics of your mouse movements and scroll patterns.
Because human movement is erratic, right?
Right. We accelerate, we decelerate, we click with slight inaccuracies.
A bot maneuvering a cursor probably does so in perfectly straight lines.
Perfectly straight lines, uniform speeds, or it simply teleports to coordinate points. If the JavaScript detects that kind of robotic precision, it denies entry.
Wow. Okay, so that covers the JavaScript requirement, but the source text explicitly links two technologies. It says enable JavaScript and cookies.
Yes.
So once the browser successfully renders the canvas image, proves its hardware profile, and solves the cryptographic puzzle, the text updates to verification successful. Where do the cookies fit into this sequence?
The cookie is essentially the cryptographic proof of your successful verification. If we go back to the bouncer analogy, the cookie is the invisible UV stamp placed on your hand once you pass the initial screening.
Otherwise, you'd be forced to undergo that extensive JavaScript fingerprinting on every single page load within b2media.co.za.
Precisely. That would be a terrible user experience. So a cookie is a small text file, but in this context, it functions as a highly secure JSON web token or a similar cryptographic signature.
Wow.
When your browser completes the JavaScript challenge, the security network generates a unique token signed with a secret key, and it sends it to your browser to store as a cookie.
So when you navigate to the next article or click a new link on the domain, your browser includes that cookie in its HTTP request headers.
Exactly. The edge network intercepts the request, reads the cryptographic signature in the cookie, and verifies that it is valid and unexpired.
And because the token is mathematically linked to your specific session, the network knows you've already passed the behavioral analysis.
Right, so it bypasses the just a moment screen entirely and routes your request directly to the content.
Okay, but this architecture implies a massive intermediary network handling all of these initial handshakes.
It does.
And the source material actually identifies this provider directly. It states, quote, "Performance and security by Cloudflare."
Yes, Cloudflare is a major player here.
Which brings us to a really interesting string of alphanumeric text displayed prominently on the verification screen. It says Ray ID colon 9F 9CD2 A9EE a 6B6B1.
Yeah, that Ray ID sits right above the Cloudflare logo.
So what is Cloudflare actually doing here?
Cloudflare operates as a reverse proxy. It sits between the open internet and the actual server hosting b2media.co.za. They utilize an Anycast network, which means they have data centers physically located in hundreds of cities around the world.
Okay, so when I attempt to access the domain, my request doesn't actually travel to wherever the website's primary server is physically located.
Exactly. The routing protocols automatically direct your connection to the Cloudflare data center geographically closest to you.
Oh, so the bouncer isn't standing at the front door of the venue. The bouncer is standing at the end of your physical street.
That's a perfect analogy, and that explains the performance aspect of their service. By handling the JavaScript challenge locally, the latency is significantly reduced.
Right, because the data doesn't have to travel as far.
And it also distributes the load. If a DDoS attack targets the domain, the malicious traffic is absorbed by hundreds of massive data centers globally.
Instead of concentrating on the single server hosting the website.
Exactly, but managing traffic on that global scale requires microscopic traceability, which is where that Ray ID comes into play.
Right, that Ray ID 9, F9CD2, A9EE, A6B, 6B1. It looks like a randomized hash. Given the sheer volume of traffic we discussed, billions of requests flowing through this Anycast network daily, how is this identifier utilized?
Well, in distributed computing systems, you can't really rely on simple timestamps to track events.
Because traffic is bouncing across different servers and time zones.
Exactly, different routing paths entirely.
Okay.
So the Ray ID is a unique, cryptographically generated serial number. It's assigned to your specific HTTP request at the exact millisecond it hits the edge network.
So every single click from every device on the planet passing through this infrastructure is tagged with one of these unique identifiers.
Every single request. It serves as a distributed tracing mechanism.
Wow.
From the moment your browser initiates contact through the JavaScript puzzle execution, the hardware fingerprinting, the cookie validation, all the way to the final delivery of the web page, that Ray ID is appended to the server logs.
So it functions as a diagnostic tool. If a legitimate user is inexplicably blocked by the behavioral analysis, they aren't just left with a generic error code.
Right. They can provide that Ray ID to the site administrator, and the administrator can query their Cloudflare logs for, say, 9F, 9CD2, A9EE, a 6B, 6B1, and see the exact life cycle of that specific request.
They can see exactly what went wrong.
Yeah, they can see which data center intercepted it, the exact algorithmic reason the JavaScript challenge failed, and adjust their security posture accordingly.
That is incredible.
It's a real testament to the fact that within these global defense networks, anonymity basically does not exist at the protocol level. Every interaction is highly granular and perfectly logged.
Okay, this brings into focus the final phase of the source text. After the screen displays verification successful, the text updates one last time to read, waiting for www.b2media.co.za to respond.
Right, that transition phase.
Which implies a fundamental shift in how websites actually exist on the internet today. Because if the reverse proxy is handling the geographical routing and the JavaScript fingerprinting, the cookie validation, and the Ray ID logging,
Yeah.
it seems like the actual destination server is entirely isolated from the public web.
It is. The concept of a web server directly connected to the open internet is increasingly obsolete, primarily due to those automated threats we discussed at the beginning.
So the origin server, the physical machine or cloud instance storing the actual HTML and images for b2media.co.za, operates in a state of deliberate concealment.
Absolutely. Using our running analogy, the origin server is the VIP room.
But it's a VIP room without any exterior doors leading out to the street.
Exactly. The only way in is through the bouncer's specific hallway. The firewall configurations on the origin server are set to drop all incoming traffic by default.
Really? All of it?
All of it. It will only accept packets originating from a verified Cloudflare IP address. It completely ignores the rest of the internet.
That makes sense. So when the screen says, waiting for www.b2media.co.za to respond, that represents the fraction of a second where the edge network, having fully validated your humanity, turns around and opens a secure internal tunnel to the origin server.
You got it. The proxy fetches the requested article and passes it back to the user. The user's browser never actually communicated with the domain's physical server.
It's totally walled off.
This isolation ensures the origin server never has to process a malicious packet or handle an SSL handshake with an unknown client, or expend resources fending off a botnet.
It simply responds to authenticated requests from a security provider.
Exactly.
Synthesizing this entire 5-second sequence really reveals a staggering level of hidden complexity. I mean, you click a link expecting to read an article. Instead, you're routed to the nearest node of a global edge network.
Right.
Your browser is hit with an invisible JavaScript payload, forcing it to calculate cryptographic puzzles, map its hardware architecture, and prove its cursor movements are sufficiently human.
And then the network issues a secure session token via a cookie, tags the entire interaction with a globally unique Ray ID for permanent logging, and finally acts as an intermediary courier to fetch the data.
From an origin server that refuses to speak to the public internet.
Exactly. What appears to be just a blank screen with a spinning circle is actually the front line of an endless automated conflict.
We're watching the infrastructure of the internet actively defend itself in real time.
Yeah. So the next time you see that just a moment screen, you'll know that the friction at the velvet rope is literally the only mechanism allowing the venues inside to remain functional.
That is such a profound takeaway.
Yeah.
Yet, analyzing this source material leaves us with a critical paradox to consider, prompted by the final wording on the screen. Performance and security by Cloudflare privacy. The word privacy is attached directly to the security branding. But as we've explored today, the fundamental requirement for navigating this infrastructure is submitting to profound behavioral and hardware surveillance.
It's a trade-off.
It really is. If the only way to prove our humanity to these automated systems is to permit edge networks to run diagnostic code on our local machines, track the micro-movements of our hardware, plant cryptographic session tokens in our browsers, and permanently log our uniquely generated Ray IDs, at what point does the vast invisible architecture designed to secure the web inherently mandate the compromise of our own digital privacy? Something for you to mull over the next time you're waiting just a moment for a page to load. Thanks for joining us on this deep dive.